Hey, what's up and welcome back to the multiverse of 100 plus data science project series. In this video, we're going to discuss about the customer churn predictions using Python and machine learning. Also, we're going to creating here one interactive web applications using Flask as well as the FastAPI. So you can see here an applications interface that's called the customer churn predictions at having some 19 row or input text with having 3 columns. So let's test it out. Let's select the gender equal to female, senior citizen, let's say no, and partner no, dependent no, 10 to let's say 1, phone services let's say no, multiple line let's say no, internet service let's say fiber optics, online security no, and online backup let's say no, video productions no, tech support no, streaming no, streaming movies no. Okay, contracts is let's say month to month, pepper billing because you don't have the pepper billing because it can check monthly charges let's say 29.85 and total charges let's say 300.5. And if I go on click on predict, and you can see churn 0.76% churn, 70% probability that it is churn. Okay, so in this one you're going to building these applications from the scratch end to end project. It's okay, you're going to using the Flux as well as you're going to testing it out in the API sections in the Postman using the FastAPI. So let's dive on that. In order to creating our machine learning model, you're going to use the dataset from the Kaggle that's called the telco customer churn. So you can read about that about the dataset, and I'm simply going to go on here, and after that I can select this CSV file. You can just click on download on here. Otherwise, you can also click on download on here, but make sure that you have an account on that. Okay, so let's go on here and try to download it, and let's go on the Jupyter notebook. Let's first import the pandas, numpy, matplotlib, and the seaborn library. So let's import it here. Let's say import pandas as pd, import numpy as np, import matplotlib dot pyplot as plt, as well as import here the seaborn as sns. So import seaborn as sns, as well as I'm going to set here on a style just called the 538. It's nothing but the PLTS style, and it will making your visualization graph more unique and stylist. So let's say plt dot style dot use, let's say 5. Okay, it could be the 5. Not like that. So let's removing this one and then give here a bracket. So it could be the 530 THIRTY and 538. Okay, shift enter, or you can using this run button from this menu. Okay, so now you can see here it will actually load it. Okay, now what I can do, I am simply going to load the data set from my directory. So for that I'm going to using here pd.read_csv, because this is an CSV file, comma separated below file. So if I see this one, if I see my data set, this is my data set that we downloaded from the Kaggle. So I copy this out, the name of this one, this data set. I'm going to copy this one, this path, and I'm simply going to go on here, and after that I'm going to paste it here. Okay, I'm going to paste it here. Okay, dot csv, and this is nothing but my data set. So let's making it df, or you can say data frame. Okay, so let's take some shell, more shell. Now let's checking the head of that. Let's say df.head. Then you can see the data set with having 21 columns, and right now it's showing the 5 rows. You can checking this how many rows are available using this df.shape. So you can see that it having 7,043 rows and 21 columns. That's mean features. And if I see it having some customer ID, Xander, senior citizen, partnership, say partner, dependent. Okay, all of the column it have, as well as you can see here inside the last one, I mean the last columns, it having another column. It's called the churn. Which one we need to predict? Okay, which one you need to predict? So you can see that it's just having the two values, no and the yes. That's mean this is an binary classifications problem. Okay, so we identify the problems types, that this is a binary classification problems. Now let's try to checking the information regarding my data set. So let's say df.info. So here you can see that is there any null value or not. Otherwise we can also checking the data types of that. So you see that we have 7,043. 7,043 rows, and all of the columns it having almost 7,043 data. That's mean I don't think that it don't have any missing value. Okay, and also you can see customer ID is nothing but objects, and the senior citizen is right now integers, and also you can see floating point number, let's call the monthly charges, and total charges is also converted into the objects. Okay, having some problem on the data set, I see that. If I go here, you can see here total charges is nothing but a floating point number, but it will conserving as this is nothing but an object. We need to do some changes on that. Okay, I mean we need to handle in the categorical value to the numericals, and numericals value to numerical value as well. Okay, so now what I can do, we're simply going to dropping this column because this customer ID is not needed at all, because it's not needed in the preprocessing time. So you can simply going to removing this one. So what I can do, you can using here df.drop. So let's say df.drop, and inside that I can giving the columns name. So let's say columns is nothing but the customer ID, Okay, like that. Okay, this capital. I hope so. Yeah, this capital. And then because we're going to dropping it out, and we don't need to actually store it in a same data frame, or you can make it true in classical true. Okay, so in classical true, why? If I using here df equal to like that, if I using here df equal to like that, so I don't need to using this in place equal to true. But if I am not going to using this df equal to, then I need to using here the in place equal to true, so that it can in placing all the value, in place all the values in our data set in a single columns. Okay, in a one column. That's it. So if we're checking this one, let's say df.hat, then you can see here our customer ID column is gone. If you are removing this in place equal to 2, it will same thing, it will dropping, it's just dropping, but it will not affecting in our whole data set. Now it will affecting in our whole data set. Okay, fine. Now let's taking all of the columns. Okay, first let's checking all of the columns then, that how many columns it have. Okay, it could be error because don't have this one. Okay, those are the columns it have, just like gender, senior citizen, and the partner, dependent, tenor, phone services, multiple lines. And those are the columns it have. That how can I checking that how many columns it have. So now let's checking his gender and try to do the value count. So let's say df of gender dot value counts, and we can see that male is nothing but 355, and female is nothing but 348. 50-50, just like 50-50. Okay, cool. So now what I can do, we can also checking for the senior citizen as well. So let's try to checking for the senior citizen. So let's try to checking for senior citizens dot value count. So we can see that 0 is nothing but 5901, and 1 is nothing but 1142. That means senior citizen is nothing but 1142. If I try to checking here the unique value, unique, then you can see 0 and 1. Okay, just having the two values 0 and 1. So if I'm checking all of the Unix value from here, that how many Unix values it has, so that we can do the level encoding as well, or if there are any mismatch in our data set, so we can also replacing this data with a null or something else, right? So what I can do, we can simply go into creating here one iterator. Let's for I in df.columns. Okay, and then what I can do, if call not in, because we are not concerned about the object. Okay, we just concerned about the numerical data. Okay, so what I can do, no, we just concerned about the object, not the numerical data. Just mean we simply going to checking all of the object types of data or string types of data, for checking that how many unique value it have, so that we can do the level encoder, right? So we can removing this 10 row, and the monthly charges and the total charges. Yeah, total charges is right now in the objects, but because I will see that this is nothing but a floating point number. Okay, so what I can do is simply going to right now we're simply going to take it as it is in a floating point number. Later on we're simply going to convert this one. Okay, so that's mean 10 euro, and the monthly charges and the total charges is nothing but the uh, numerical data. So we can copy this out. Okay, not column in, not column in, let's say 10 euro, then the monthly charges. So let's say monthly charges, uh, monthly charges. Why I'm doing that, then you can understand when the output is coming up, and total charges. and then here you go. Okay, not in column. Then I'm simply going to printing here the column, as well as I'm going to printing here the df column dot unique. Okay, all of the column. Then I can simply go into printing here just one single thing, just lay this one. Okay, then you can see in the female male two values, cool, senior citizen, yes, no, no, yes, no, yes, no phone service, DSL, fiber optic. Okay, I don't see that. Is there any problem in here? No problem, no problem. Next month, yes. Churns and then no churns. Okay, okay. So all of the things are mostly okay, mostly okay here. So let's checking here the null value or not. So let's say is null dot sum, and we also checking that if you don't have any nan value at all, you don't have any nan value at all. So now what I can do, we simply going to uh, do the same thing, for this categorical column as well. Okay, do the same thing for the categorical as well, and also checking here. Okay, what I can do, I am simply going to I'm going to copy this one. It's needed or not. So let's checking for the numerical value. Okay, let's taking some shell. Okay, that's a for call in. Just going to copy this one for the numerical, and I am going to pass it here because this is a numerical value. It having so many values at all. So what I can do is simply going to checking for the length of that. Okay, so let's say print the call of the length of the df of call. Okay, and we're checking that in our numerical data, it having any spaces or not. If it having a spaces or not. If it is having a spaces, we need also removing this one. If I see this one, it may be having some spaces. Maybe having some spaces on that because I see the data set and it having some spaces on that. So how can we handle in this one? So we can check in the df of df, okay, df of df is nothing but equal to blank spaces. Then we can simply go into printing it out, and otherwise, not otherwise actually, we simply going to printing it out. And let's give it here one thing, so that is the cool. Okay, and you can see that inside our total charges, it having the 11, spaces, because this is nothing but in a string format, in an object format. It's not in the numerical format. Okay, if it having numerical, it will removing automatically removing the spaces. But for the string, spaces is important. Space is also in a string. So when you have the data in the form of objects, you need to make sure that you don't have any spaces, because this is in a numerical format, but the data type is objects. That's why I need to check in this one. Okay, now we see that in our this one we don't have any problem in string. We don't see any spaces on that, but for these cases we see the spaces. Now what I can do is simply going to replace in this one. We can replacing this one. So let's say df of, and we can using here the total charges. Let's say total charges, okay, total charges, and equal to, now you don't need to using the replace in place equal to true, right? So df of total charges, okay, dot replace. Okay, क्या replace करना है मुझे? So we replacing his blank spaces with the 0, okay, 0.0. Okay, it having some blank space as well. I mean, it don't have any value. That means actually it actually making this one, thinking this one, you don't have any nan value because it is string. Okay, so and now after that, I'm simply going to convert them to the float. Let's say s type equal to float 32 or float. That's making it float. It will automatically converting this one. Now if we're checking this one, let's say df.info, then you can see here it's converting to float 64. Okay, na boss? Okay. Okay, cool. Now let's try to do some analysis on our churn. Which one is asking about our target column? Let's say df of churn. Dot value counts. Okay, then you can see one thing, important thing actually. Though is nothing but 5,174, and whereas EF is 1869, and data set is cool. It looks like the imbalance. It looks like the imbalance data set. So in order to handle in this one, so what we actually do, we remove the customer ID, right? In a nutshell, we remove the customer ID. Then we're checking for the missing value, if having any missing value in our data set or not. Then we see the missing value in our total charges, and we also replace with the zeros. And also we see that it having some class imbalance. Okay, that's mean this is an imbalance types of data set. Okay, so you're already solving those so many problems using uh, using machine learning, just like the credit card fraud detections, having the high imbalance data. So using here the oversampling and the undersampling technique to actually handle this out. Now we see that we have the lower number of data. We have the lower number of data. But let's try to do some exploratory data analysis on that. So let's say exploratory data analysis. Okay, you can go on the markdown. You can make it markdown. Okay, now let's checking the shape first. Shape is right now 20. It just having the 20 columns, and now we can checking all the columns as well. uh, yeah, those are the columns it have. Okay, the last one is called the churn. Now let's try to describe. So let's say df.describe for checking here how many numerical column it have, and also the count the mean, the standard deviations, and the 25% percentile, 50%, 75%, and the maximum value. Okay, we see that senior citizens count is 7040. That means you don't have the missing values, and mean is nothing but 0.16 and 32, 64, and 2279. Okay, so this is about the you describe descriptive analysis of your data. You can also making it like that in the transparent panel. Okay, transpose. Okay, now I am simply going to define here functions, so which can help me to see the distribution of the plot, just like the hist plot, so that you can see the distributions of the of our data set, and you can add it to the UTCs or the presentations. Okay, so let's say plot and distribution. It's important to do the data analysis because it's important for selecting the features, as well as you can, if you're doing any projects for your university or college, so you can add it down. Okay, that's already this is the data set, how it look like and how it distributed. So it will taking one df, I'm our data set, and also one column name. Okay, so column name. So what I can do now, we can simply go into creating one figure. So let's say plt.figure, and you can giving here the fixed size. So let's say fixed size of, let's say 12,4. Okay, it's pre-computed. And plt dot subplot, because we're going to plot here two plot. One is a hist plot or histogram plot with the axis line, and another one is called the box plot for actually saying if they're having any outlier or not. Because this is a customer churn data set, so it may be having the outlier. Okay, so what I can do, you can using here 1 2 comma 1. Then after that, you can using here sns dot hist plot, and inside it I can pass in my column name, which column is coming from the parameters, and after that I can giving here kd equal to true. Okay, then I'm going to using here title, let's say plt dot title, and I can using here one f string. So let's say distribution of the column, which one is coming. So let's say column name. Okay, so it's coming gone. And now we need to creating here one axis line of the mean and the median, so that we can see that which one is a mean value and which one is a median value. Okay, you can see here in the form of the values, in the form of the values, you can also draw the outline on that. So how can you do that? So you can using here df of columns, name, and you can taking the mean of that. Okay, so it should be our column mean. So let's say column mean, and you can also do the same thing for the median, for checking the median. So let's say df of column name dot median, and this is should be our column median. Okay, so it should be column median. Fine, now let's try to creating here the axis line. Let's say plt dot xb line, and then we can giving here column mean, and then you can giving the color, let's say red color, and then you can giving the line style equal to dash dash, and then we can giving here the label is nothing but the column mean. It should be the mean. Okay, and I can copy this out from here, and after that I can simply going to pass it here and changing this one to be column median, a column median, and it should be the, let's say, blue. You can give any color on that, and label is called the median. Okay, cool. Now let's try to add one legend, and then let's getting here the another figure. Let's say pld dot figure. You can give or not because it's auto computed from here, and you're already giving the figure size, so you don't need to actually give it here. And now you can giving here the subplots number 2. So let's say 1 comma 2 comma 2. Okay, it's the subplots. And after that, what I can do, you can using the box plot. So let's say box plot, and inside that, in our y directions, we can using here the df of column name. Okay. Oh. So you can give in here the plt dot titles. Pigeons are disturbing so much. बॉक्स प्लॉट, कबूतर बोलते हैं ना, कबूतर बहुत डिस्टर्ब कर रहे हैं, छोटे 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 छोटे. Now you can using a plt dot show. Okay, then now what I can do is simply going to run it out. Now let's try to copy this out, these distributions, and then you can passing here our data frame, and then we need to giving here the columns. So it's nothing but the 10 row. Okay, and you can see here how it will look like distribution of the 10 row, and this is the mean of that, and this is the median value, and we don't see any outlier on that. Okay, if it is having an outlier, you can actually removing this one. It having so many techniques, it's called interquartile race, or so many techniques it have. But yeah, it's important to removing the outlier on the data set because it affecting your affected when you're actually creating here the machine learning models. Okay, we're also creating here another tutorial on that how can you actually removing the outlier from your data set. And I'll try to creating here another series for that basics of the machine learning, that how can you actually uh, implement the linear regressions from the stress without using any library. It's called the scikit-learn from the SQL, just mathematical term on that. Okay, now let's try to use for the monthly charges. किधर पे इधर जो तो कॉपी करके दो तीन टाइम पेस्ट करना चाहिए. So it could be the monthly charges. So you can copy this out, and I'm going to pass it here. And after that, I'm going to copy this one. It should be here. And then here we go. And I'm going to running. Okay, it's already copied. I'm going to running this one. Okay. Thus you can see here the monthly charges, how it will look like. And you can see that for the total charges, it is near to the 2000s. Okay, and distribution looks like the 10 inch. Okay, it don't have any normal distribution. I see that, and there's a box plot. It don't have any outlier on that. Okay, and you can also see that the how the mean and the mode is actually look like. Okay, for this one you can see here also, you can also calculate the mean. Okay, you can see the mean, and this mean is also similar. And if I see this one, mean is nothing but coming for the 60 up after 60, you can see after 60 having a line. And same thing for here 30. So mean is nothing but after 30, and you can see after 30. Okay, quite similar on that. You can also see in the box plot as well. Now what I can do now, we see the data, right? Now let's try to do the correlations. See the correlation matrix. So correlation is we can plot it out in the numerical data, because we needed to think about the categorical data as well, because it's nothing but 0 and 1. Okay, so what I can do is simply going to creating here on figure. So let's say figure, and inside that you can giving here the fixed size of, let's say, 8,4, and then we're simply going to creating here one heat map. Okay, heat map of df of, we have the 10 row, then we have the monthly charges. Okay, was charges, and then we have the total charges, charges, bus total charges, and taking the correlation for that. Let's say core, and then I can giving here anode equal to true. Then I'm going to giving here cmap थोड़ा 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 अच्छा cool ठंडे वाले देते हैं cool worm. And then I'm going to using here the fmt. You can give it or not, it's up to you, but let's give it here the fmt. It's the best choice to do that. So let's say point to f. Okay, then after that what I can do, we're simply going to add one title on that. So let's say plt dot title, and then you can giving the correlation matrix. Here you go, and using here plt dot show, and then you can see the how it correlated, and you see that it's nothing but 43% correlated with the 10 row to the total charges, and this is the diagonal bird, and you don't see any correlated matrix as well. But yeah, it's mostly correlated. You can as well as you can choosing the Tanru or the total charges, you can choosing one of them. But because it's just having the three features, so you can take it out. Okay, we don't need to actually removing this one. Okay, if you want to learn more about this one, you can also check in the rainfall predictions how you actually do the feature engineering. How can you take in the features if it is highly correlated. Okay, but I said yeah, it correlated highly correlated, but we don't need to removing this one because it's just having the three features. Okay, so now what I can do, I am simply going to do another distributions for checking, because we see that our class is imbalanced. So we're simply going to first checking the categorical column as well, because we already do for the numericals, but distributions, but we don't do for any categorical things. So let's try to checking for the count plot of the categorical plot, categorical uh, columns. So let's df dot select d types, and which one include, taking one include, if it is include the objects. Okay, objects, and we have using here the columns. Okay, columns dot to list, and you can passing here list, and you can simply going to adding here the senior citizen. Why senior citizen? Why? Because the senior citizen is not an numerical column. Okay, it's the category column. 0 and 1 by default coming 0 and 1. 0 means no, and 1 means yes. That means this is the category column as well. So we can simply going to taking it out. So let's say senior citizen, we simply going to add it out. And now let's try to creating here on iterator. Let's say for I in categorical columns, and after that I can using here one figure. Let's say plt dot figure, and after that I can using here the fixed size, not keep size actually. Fixed size equal to, let's say 6,4, and then I can using here sns dot count float, and inside that I can passing my data is equal to my df, and the x is nothing but my column, and hue is based on the churn. Okay, and then I can using a plt dot title, and let's say use the string, and let's say call distribution by churn, and then I can using a plt dot show. Okay, now you can see here the gender distributions by churn, and you can say that yes is too low, yes is really very too. You can see here instead of phone services it's too low. You can see here too low. Okay, too low. No is high right now here in the text support, and you can see yes is for the no intent service too low. That's when we see that some imbalanced, okay, some imbalance problem in our data set. Okay, in our data set. Now what I can do now, we simply going to say the distribution plot, box plot, as well as we see the correlations, and we have the count plot as well, and you can checking that how the data look like and how the distributed it, and you can also just checking for the without the hue, you can also checking for here, just let's say sns dot count plot. You can just checking here uh, the x equal to column like that, Is it okay? Y equal to, let's say y equal to df of column, like that. Let's checking this one, and you can also check in this one that how it will look like. Okay, you can also making it x, and you can see that how the distributed look like for the count plot of each of the columns. Okay, this is nothing but for the just one columns. Okay, it having, and you can see the male and the female is equally distributed on here in the gender, but for here you can see that it just having no is so little bit in the phone services. Okay, so you can do different kind of analysis on your data set. Now let's try to do the level encoding. So let's say level encoding, because it's needed to actually um, converting these categorical values to the numerical as well. So now what I can do, first I'm going to convert the churn. Let's say churn into 0 and 1. Let's say df of churn. Okay, df of churn dot replace, and you can using here, if it is yes, if it is yes, we can convert them into the 1, and if it is the no, then we can convert them to the 0. Okay, this is nothing but for the one column just at all. So you can check in, let's say df.info, then you can see here it is converted into the in64. Now if I are going to actually select all of the objects columns, so how can I do that? Let's say objects columns. Okay, columns to df dot select okay d types. Okay, d types, and we can using here include equal to objects. Okay, objects. Okay, then we can simply go into making these columns. Okay, now see that, sir, we already doing this out in here. I hope so. Yeah, here. So why we are going to using it here extra objects column? Because see, this senior citizens is nothing but in the form of the string. So we can do the level encoding on here because it's already 0 and 1. So you can simply going to actually replacing the data type. Okay, so that's why you're creating here the new column for the objects columns. And now what I can do is simply going to passing these object columns um, to our level encoder. So for that, what I can do, we simply going to import it from the sklearn. So let's say from sklearn.preprocessing, we are going to importing here the level encoder. Okay, that's level encoder, and then I'm going to actually uh, creating here one instance of the level encoder. So what I can do, uh, we can storing all of them. Okay, let's encoders. We can storing all of the encoders in a list so that you can use it in our Flux applications. And then we're simply going to iterate to all of the columns. So let's say columns in objects column. Let's say objects columns. Okay, that's our objects column. And then after that, what I can do is simply going to call in this level encoder, because you're going to store in this encoder in a list so that we can how in actually creating here our applications, and for the deployment purposes so that we can using these ones. Okay, because it's important, the level encoding is important at all. Same encoding technique you need to using on here while creating here the applications. So this is nothing but my level encoder. That's our instance. And now using this level encoder instance, so what I can do, I am simply going to fit it out. So let's say level encoder dot fit underscore transform, and inside that I can passing here my df of column. Okay, so this is nothing but in my same data frame. So let's say df of column, and here you go, and then we can pass in this one inside my encoder. So let's say it's the encoders of the column, and then I can passing here the level encoder. Okay, and here you go. Now our encoder is ready, and if I going to open this one, and then you can see here how it will look like all of the encoder it have. Okay, so I am simply going to saving this out. So let's say with open, then I can use it here. Let's say encoder dot pickle file, and then I need to giving here the mode wb mode sf, and also I need to importing here the pickle. So let's say first pkl dot dump, and then I can passing here the encoders, and then I can passing here my file name. And also I need to importing here the pkl. So let's say import here the pkl. Okay, any problem? Any problem? Inbuilt. Okay, issue with the s. Okay, fine. Now it will dumping on at, you can see encoder.pkl file seconds ago. Okay, you can also loading this out as well. Okay, so now what I can do, now I am simply going to uh, building our machine learning model. But before that, you need to also do the standard scalars in our data. Okay, so what I can do, we can using here from sklearn dot preprocessing. We are going to importing here the standard scalar. So why a standard scalar? If I see our data, called uh, monthly charges, you can see how it will distribute it. So you can simply going to make it a normal distributions in the range of 0 to 1, so that our machine learning can easily getting all the patterns and try to building our model as well. So that's why you could using here the standard scalars. Now what I can do, I am simply going to running this out, and after that I am simply going to taking all the numerical columns. So let's say numerical columns. So we have the three numerical columns. One is 10 row, and another one is called the monthly charges. Pigeon is disturbing too much. So monthly charges. Mom bahut marega isko. Monthly charges, and then it covers a total charges. Okay, total charges. Then what I can do, I am simply going to creating here on instance of the scalars. So the scalar equal to standard scalar. So it should be the standard scalar, and then after that I'm going to fitting it with the numerical column. So let's say df of numerical column. Okay, and then we can using here scalar dot fit. Okay, and underscore transform, and inside that I can passing here my df of numerical columns. Okay, and now it will converted this data in the form of 0 to 1. Okay, now what I can do, I am simply going to importing all of the important library which one is required in order to building our machine learning model. So because this data set is imbalanced, so that's why I need to also using here some imbalance kind of technique. So for that I can using here this smooth technique from the IMB learn. So let's IMB learn. So IMB learn IMB learn dot over sampling. Why over sampling? Because we have the less number of data. Okay, we have the less number of data. We can removing all the data from here. Okay, because if I see that in the churn, so if I go on here and if I checking the value count of the churn, so let's say df of churn dot value counts. Okay, then you can see it has just having the 0 and 1. Okay, 0 and 1, you can see 5 174 and 1869. So it just having the last number of value. So if I removing this one, if I do the undersampling, so the 0 is also converted into 1 and 6. That means how so many data should be removed. So it's not a bad practice to use the undersampling on here. If you have the large number of data set, you can using the undersampling. But also one more thing, just for confirmations. So let's start using here df.info, and you can see that yeah, all the data is converted into the in64. Cool. Now this is the oversampling. Now I'm going to importing here the smooth. Okay, so smooth. Now what I can do now, I am simply going to actually import one more important library called sklearn dot model selection. I'm going to importing here the train test bed. So you can using here actually the ML flow on that. You can also use the ML flow, and I will creating the videos about the ML flow, that how can you do the experiment in you using the ML flow. You can store all of your parameters grid, and you can also do the hyperparameter tuning, and you can store it on that. Okay, so let's say importing the cross validation. It is needed. Let's try to import it out. If it is needed, then you can actually using this one cross validations and the grid search because you're going to do the hyperparameter tuning on that. Okay, then I'm going to importing here from sklearn dot ensemble. I'm going to importing here the random forest classifier. oh aja random forest classifier, and as well as I am going to import the xzb post, import the xzb post classifier. Okay, xzb classifier. Then from sklearn dot matrix, I'm going to importing here the accuracy score, the confusion matrix, confused kar deta bhai, and the classification report, and then we have the ROC AOC cup, and then nothing, nothing else. Okay, now let's creating our dependent and independent features. So let's x equal to df of drop only churn. So columns equal to only churn. So let's say churn, and y is nothing but our churn. So it should be df of churn. Now let's pass it to our train test and split. So let's pass in this out, and then we have the x and y, and the test size equal to 0.2, and then we have the random state equal to 42, and it should be the x train and the x test and y train and the y test. So it should be the x train and the x test, oh, and the y train and the y test. So now what I can do, we can checking the shape of that, and you can see the shape is look like that. And if I start to checking the value counts, oh, value counts, then you can see here one is nothing but 4138 and one is 1496, and some of the data is go on the y test. Now if I am using a smooth, then you can see what actually happening here. If I am using a smooth, oh, smooth, and then I'm going to using the random state so that it's not changing the state as well when the new user is coming up and try to run in this notebook, it's not changing the state all others. So let's say random state equal to 32, then I'm going to making it smooth. Now let's try to use it for the extend and the white train. So smooth dot fit resample, and it should be the x train and the y train. And now it having the x train and the x train is smooth. And the question is, sir, why not you actually applying the x test and the y test? Because it's testing data. It's the testing data, it's unseen data, we need to testing it out. So why should you do the smooth on here? So let's say y train smooth कर लो भाई, smooth से कर लो बस हो गया. Now if you try to checking this one, the shape of that, then you can see one more magic दिखना है तुमको, magic से देखना होगा. देखो 1 हो गया सेम 4 and 3 8, 0 हो गया 4 and 3 8, सेम हो गया बस, सेम हो गया. This is the example of resampling, I mean over sampling. If you do the under sampling, then the data should be reduced. So it's not a good practice to reduce your data, important data, because data is important. Now what I can do is simply going to adding our models. So let's say models equal to, let's add here two models. So let's say random forest, and then we can using here the random forest classifier. And then you can using the same random state. Is equal to 42. Then you can using here the xg boost, and it should be the xgb classifier, and then you can using the same random state equal to 42. Okay, that's our model. Now let's try to do the hyperparameter. Okay, let's take some more shell, and let's say hyperparameter, and it having the first random state, sorry, random forest. So in the random forest, it have the number of estimators. So let's say number of estimators. Okay, estimators. So it should be the, let's say started from the 50, and let's say 100 and 200. And for, well, so now let's adding here the max depth. So let's say max underscore depth. So it should be the, let's say 5 comma 10 comma 9. Okay, fine. Now for the random forest is done. Now let's do it for the expost. So let's say expost. Oh, boast. Boast. And for the expost, the hyperparameter is nothing but called the learning rate and the max depth. Okay, so let's give it here. That's called the learning rate. So let's say learning rate, and then we can give in here, let's say 0.01, and let's say 0.1 and the 0.2. Okay, so learning rate is the nothing but called the rate of the learning, and high end for the go to the global minima point. Okay, then what I can do, you can giving here the max depth. So let's say depth is nothing but, let's say 3 comma 5 comma 7. Okay, any problem? You have to give here on comma and comma on here and enter. Now you can see our hyperparameter is done. Now what I can do is simply going to tune our model. So for that, you're going to use the iterator. Let's say for model name and the model in models.items, because we already initialized these models, and we're going to taking here our model's name as well as our model, because it having the model's name is random forest and our model is this one, this classifier. Now what I can do, we simply going to actually printing here one thing. Let's say call because this is a hyperparameter tuning, let's say tuning. Okay, tuning. Okay, then we can give it to the model name, so that you can see that which model is actually tuning in here. And after that, we can give in some dot 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 dot. Okay, that's been loading signs. And after that, what I can do is simply going to use the grid search CB, because you're already importing here the grid search CB for the hyperparameter tuning. And inside that, I need to giving here the estimator, and estimator is nothing but my model. And then my param grids, that's my param grids is nothing but my hyperparameter tuning, hyperparameters that actually initialize on here, and based on that, you can giving here this model name. Okay, so what I can do, you can giving passing here the model name. And after that, you can giving here c equal to 3, sorry for that. And then you can using here scoring. Scoring is accuracy, and then we can add it to a variable called grid. So let's say grid equal to, and then using this grid we can do the fitting. So let's say fit equal to xstring. Okay, smooth data. And as well as you can passing here the white range smooth data, sorry for a problem. Okay, smooth. Okay, so we actually creating here, initialize here our grid search CV, and we passing here the estimators, the param grids, as well as the cross validations. How many fold? 3-fold. Then we're giving here the scoring equal to accuracy. Okay, you can also making it, let's say we can give it to the 5-fold as well. Now what I can do is simply going to save it inside one dictionary that's called the best model. So that's the best underscore models. Okay, it's nothing but a dictionary, and inside our dictionary we're simply going to pass in here our models. Okay, so what I can do is simply going to copy this best model, and inside this best model we're going to pass in here our model name as well as my grid dot best parameter. So that's the best estimator or the parameter best estimator. Okay, that's mean inside our best model we simply going to passing here our model name, so that we can start it later. Okay, and after that we simply going to printing it out. Let's say printing here the, let's say best parameter. So you can say that, let's say best parameters. Okay, parameters for, and simply going to pass it here the model name, and then we can using here, let's say grid dot best params. Okay, it should be the best params, best parameter. And after that, you can say simply going to printing it here the best accuracy. So let's say f, let's call best accuracy. Okay, should be the accuracy accuracy for model name. Okay, and then we're simply going to using here the grid dot, okay, grid dot best score. So you can using the best score, it's nothing but the accuracy score, and you can, that's making it point to f. Okay, that's it, and you can give it a backslash n. And now you can see here our random forest model is tuning right now. And you can see here tuning random forest dot 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 loading sign, and it will using the fold of 5-fold, and it will try to checking for the accuracy score, because in our scoring we actually giving the accuracy, and you also fit with our smooth data. That's our smooth data. Here you go, this one. And after that we can simply go into searching for the best estimator, which will be the best estimator, and also checking for the best parameters and the best accuracy. Now, when it is done, after that, what I can do is simply going to save our model, which one is the best model. So what I can do, you can using here with open, okay, with open, and then you can using here, let's say best, okay, underscore model dot pickle. And then after that, it should be in a write mode. So let's say WB write mode as F, okay. And after that, what I can do, you can simply going to dump it out. Let's say dump. So why this one? Because we're going to creating here the web application. So that's why this pickle file is actually needed in order to actually building the web application, so that you can use it later on. And inside that, what I can do, you can pass in here my best models. Okay, that's best model is nothing but this best model. And inside this best model, you can see here the random forest we got here 85% accuracy, and max depth is nothing but none, and number of estimated is 200. So 200. Okay, now from this best model, which one having the best accuracy, you're going to choosing this one. So you can see there for the random forest, the accuracy of the best accuracy is nothing but 0.84. Which one is nothing but, because we give him the cross validation, is nothing but the 5. Okay, after 5-fold it will taking here the best one, which one is needed, and we got here the max depth is nothing but the none, and the estimate is 200. Now for the XG boost, you can see here learning rate is 0.1 and max depth is nothing but 7. That's mean we see that the random forest having the best accuracy. So from the best model, if I try to printing this best model, then you can see one thing. If I printing this best model, that you can see we have the random forest and this classifier, and inside that you have the XGBoost as well. Okay, so what I can do, inside the best model, we can see that random forest having the best accuracy, that's like 84%. So you can choosing the random forest from here. Okay, so you can giving here the, let's say, random forest. Okay, random forest for best model, and we're simply going to save it out. Simple. Now if you go on here, then you can see the best model is saved on here, is a 49.1 MB, right? So now we need to also save our scalar. So let's say with open, and then a scalar, okay, a scalar dot pickle file, and then you can using here WB. Okay, same thing as F. So why a scalar actually? Because see, we're using here the standard scalars in just 3 classes, or sorry, 3 columns: 10 row, monthly changes, and total charges. Sorry, and we need to also saving this one, because while actually creating the applications, we're also using this scalar technique to make it transform, reverse transform. Okay, so that's why it also dump it out. Let's pickle dot dump, and inside that you can passing here our scalar, and that's. Now you can see here the scalar is also saved. You can see scalar is also saved. Okay, so now what I can do is simply going to do the predictions using the our best model is starting with the random forest model. So what I can do, you can using here best underscore models, and inside that we have the random forest. So we have the random forest, and inside the random forest we're going to using here the predict, because we have the testing data. So let's say x test. Okay, x test. So that's our x y test predictions. So it should be our y test prediction. Here you go. Right, now let's do the same thing. Copy this out and paste it here, and this is nothing but for the probability. Okay, let's say probability, best model, random forest, and predict proba. Okay, predict proba. Okay, and inside you're passing the x test, and you're taking the all of the value from 1 to 1, and that's our probability. And if I try to checking this one, and then you can see here that's our predictions, and if I checking the probability, then you can see the probability of that. Okay, of each of the testing value. Now what I can do, we can printing here our accuracy and RLC curve and all the things for the testing data. So we can printing it in a single line. Let's say print the, let's say using the F string, let's say accuracy for, okay, accuracy, just accuracy. Then inside that you can passing here, let's say passing here accuracy score, and inside it passing here y test, and the y. Okay, it should be y test pred and the sorry, y test and y test predictions. Okay, y test predictions. Okay, that's it. And you can see here 77% accuracy. So let's do it for the B1. So I'm going to pass it here the 4 times. And we have the ROC AOC score. So let's say ROC AOC score. And then we have the confusion matrix. So let's say confusion matrix. Oh, matrix. And then we have the classification report. Let's say classification report. So it should be the ROC AOC curve. It should be the confusion matrix. Confusion by confusion ho ja. Confusion matrix. Then you have the classification report. Okay, and you can see here that's how it look like. 77% accuracy on that, and ROC is nothing but 74%, and that's our confusion matrices. And we can give it here a black space so that it look good. Now it look good, and we can also give it on here. Okay, now you can see look good. So this is the precisions, 87% quite good. Recall 82%, 85% in the this support. Okay, accuracy 78%. I mean 77% at all. Okay, quite good, not so bad. But we can also make it more realistic or make it more tuning using the deep learning. You can also using the deep learning technique on here to actually making it more cool as well, because this is the imbalanced types of data set. Okay, so accuracy is also very as well. So now what I can do, we simply going to save all of our things, just call a best model and all of the things, right? So we save here as scalars, the best model. You also save our encoders. So now we can also load it out. So let's say that's how can you load it out. Let's open, then we can load it called best models .pkl in the right mode. Okay, because you need to also know that how can you load it our model from in our code. So we can, let's say, loaded model. Okay, then we can using here pkl dot load f. Okay, same thing for here. Let's say with open, then you can using here, let's say, encoder dot pkl, and then you can using here, let's say, rb, let's say sf, and same thing here. That it is nothing but the encoders. So let's say encoders equal to pkl dot load and inside f. Okay, same thing for the scalar. So let's say with open scalar dot pkl, and in the mode is nothing but the right mode sf. Then we can using, let's say, scale data, let's say scalar underscore data, and here you go. You can using here pkl dot load load, and inside you can passing left. So our model is loaded, right? That's model. We are going to load it out here. So now what I can do is simply going to creating here a function which can actually help us to do the predictions. So let's say def make prediction, and inside that you can passing here the input data. Okay, and then what I can do is simply going to take in this input data. Let's say input df equal to pd dot data frame, and inside that you can passing here our input data. Let's say input data, and then we can passing here, let's say, for call and the encoder in encoder dot items. Okay, encoder dot item. Why? Because in the encoders it's having various encoders, so we're simply going to iterate to all the value from here which are having the columns, and based on the columns we're simply going to do the transformations, right? So we can using here input df, and inside we're passing the columns, and based on this column we're simply going to transform the data. So let's say encoder. Okay, that's our encoders. Encoder dot transform, not fit. Okay, because we're testing it out. Transform, and inside it we're passing the input df of the column. Simple. And after that, for the scalar, we need to also actually initialize here our numerical columns. So here we go. We can go on here. You can copy this out, this numerical column, and you can pass it here. And now in this numerical column, we simply going to apply here our scalar transform data. So it should be our scalar data. So scalar data dot transform, and inside that we passing here the input df. That is nothing but coming from the in the form of the parameters, and we simply going to pass in here our our columns. So this column is nothing but our numerical columns. So that's our numerical columns. So it's simply going to transform it, okay, for the scalar data. Now it's inside our input df. So inside our input df, we're simply going to pass in here our numerical columns. Okay. See, we first taking the data from the users, and after that, we're simply going to making it a data frame. And after that, we're simply going to iterate to all the encoders from the encoders and try to transform it based on my input column. Now, based on the input column, we need to also do the external scalars. Okay, we need to also do the transformation on that. So that's why we're simply going to creating here the numerical columns, and after that, we're simply going to transform it. Now we need to do the predictions. So let's do the predictions. So let's say predictions equal to loaded model, okay, dot predict, and then inside there let's passing here the input tf, okay, and we simply going to take the first index on this. So you have the predictions. You can also checking for the probability, probability, like that. And then you can using here the loaded model dot predict predict proba, and inside that we passing here our input df. So the probability is nothing but from 0 to 1. Okay, then we simply going to return here, return one more thing. If the prediction is equal to 1, then we simply going to return here the churn. Okay, churn. Otherwise, you can simply go into using here no churn. It's nothing but a nested if else. Okay, churn. Okay, and we're simply going to passing here the probability. Okay, so our function is ready. Now what I can do is simply going to give here our examples input. So what I can do, we have the df dot columns. So those are the columns. So what I can do is simply going to getting here an example input. So let's create it out. So we have the gender first. So gender. So let's say gender is nothing but let's say female. Female. Then what I have? We have the senior citizen. So copy this out. Okay, senior citizen. Okay, so for the senior citizen, let's say making it 0, and for partner, and let's say making you have the partner or not. Let's say yes, it have the partner. Let's say yes. Okay, then dependent, let's making it dependent. Okay, let's making it let's say no dependent. Okay, it's nothing but testing data. Okay, you can test it out on here in the applications. And tenero, let's say making it let's say 1, and let's say phone services. Let's say phone services. Let's say it having the phone services, no phone services, and the multiples line. Okay, let's say multiple lines. Let's say no phone services. Okay, no phone services. So phone services. Okay, it's better. I will type it this out, and after that I get again actually, because it's so many column. I need to type it here, and I'll type it manually and stop the recording. Okay, I type it out here, and you can see gender is female, senior citizen 0, partner yes, dependent no, tenor 1, phone services no, and no phone services DSL, the online security no, online backup yes, device protection no, tech support no, streaming taping no, and this is no, month to month yes, and electronic check and the monthly check, and this one. Okay, this is nothing but one example input. Now using our make predictions, we simply going to calling this one. Okay, this make predictions, and using this one, we simply going to pass it here our example input. So it's nothing but our predictions and the probability. So what I can do is simply going to store our prediction and the probability. Okay, it should be probable. So okay, example input is not defined. We need to also running this out, and now it's running. So we can see the predictions. Oh, that's our prediction is no churn. Okay, and the probability is nothing but let's say I'm going to pass it here, and probability is nothing but 26%. Okay, so you can simply going to print it out as well. So let's say f equal to let's say prediction, and let's say we have the prediction, and then you can using the comma, and let's say probability. Okay, it's not here. Okay, it should be here. Go, and then you can using here the probability. Okay, probability is nothing but call, let's say proba. Okay, prob, and then you can using here dot to f. Okay, and here you go. And prediction is no churn, probability is 26%. So you can also send something on here, and after that you can get here churn as well, because it is a no churn data. So that's why. So now what I can do is simply go into creating here our web applications using the Flask framework. Flask framework. Okay. You can also develop this application in the render as well. Okay. But here we can see that our model file is nothing but the 49 MB. So we can upload it to the GitHub. Okay. But later on I'll show you that how can you upload it in the render as well, or the AWS. In here you can actually upload it for the deployment purpose. So we're simply going to creating the web applications using the Flask framework. Okay, application using Flask. Okay, so now let's try to building this one, and after that our tutorial should end. Okay, so let's go on here. Well, right now we are in a VS Code, and I will write the code for the Flask applications, and you can see here app.py file. This is nothing but server-side code, and as well as inside this template folder, you can see here our index.html file is nothing but our UI file. Okay, so what I'm going to do, I'm simply going to first running this app.py file, and after that I'm going to go through these UI sections and try to explain with you, right? And after that you're also creating here another file for the FastAPI. Okay, so we're going to testing this application in the FastAPI also, but in a JSON format. Okay, so what I can do, I need to go on here. So let's go on here, follow link, and then you can see here that's our application, how it will look like. Okay, so you can see here it's just having 3 columns, and inside each of the column it having some kind of input boxes or some drop down. And also you can see here at hand one heading that's called customer churn predictions, and you can see here one button called the predict. Okay, so now let's go on the code. Okay, so what I can do now, I'm going to go on our index.html file, then I'm going to teach you that how this UI actually built it. So in this case you're going to using here the bootstrap. Okay, so you can see customer churn prediction is nothing but my title, so you can see this is the title, customer churn predictions. And also we adding here our bootstrap in here, and after that we simply going to creating here on container, and inside this container we having one h1 tag and having customer churn predictions. And as well as we're creating one from, because you know to taking the input from the users in a from. So that's why I give here the from, and method is nothing but the post method. Okay, post method. It have been so many methods are available, just like get method, post method, put method, delete method. Okay, so you're going to using here the post method because you're going to take in the data from the users, and after that we're simply going to give some responses using that. And we have the class is nothing but empty4, that is nothing but margin topper. Okay, so, and after that we're simply going to creating here on div. This is the first column. Okay, in the first column we're simply going to add here our genders, and the class for that is nothing but the genders. Okay, so you can see just getting here on columns of the md5 and also mb3 is nothing but for a column for the nothing but 3 columns. And if I see on that, you can see 1 2 3 4 5 6, it nothing but 16 18 and 1 19 classes it have. Okay, and each of the classes is nothing but divided into 3 columns. Okay, now in each of the columns it having the genders. Okay, we're simply going to creating here a level for that. So if you see on that, you can see gender is nothing but the levels. Okay, and after that we're simply going to select the id, because you need to select the data from this gender. So that's why it give here the value is nothing but the male and the female. And if I go on here, you can see I can select the female. Okay, and after that we have the options, same values. And after that we're simply going to creating another one for the first column. Okay, for the first column it's nothing but the second one. Okay, the second one having the senior citizen, you can see the senior citizens. Okay, adding here the select, same id and the name. So here name is important, because we're going to calling this data, or when the user take, I actually give the input in the UI, this data is directly connected to this app.py. So that's why I need to also remember this name one. Okay, and after that we give here class, because this is a bootstrap class, right? And then you give here the options that 0 or 1 is nothing but the value. and then you're having the partner. Okay, same thing for the partner, and you have the dependent. Okay, then you have the 10 row. Okay, so for the second column we have the multiple lines. Okay, it's nothing but here you can see 1 2 3 4, just going to creating one of them, just one column, second column, and third column, like that. And after that is simply going to joining all of them. Okay, so you can see here second column is nothing but same things. Okay, just adding here the multiple lines. You can see here it's nothing but the option inside the select tag, same thing. Okay, same thing for all of the cases, you can same thing. Okay, same thing, you have the third column. Okay, third column started from here. Okay, here, and after that we having one button, its type is nothing but submit, and then we have a button name called the predict. Okay, so this is the extra part, this is for ginger tablet part. When the output is coming up here, it will trigger. So now let's go on the FastAPI file, and after that you can see here we importing here the Flask from Flask. We imported the Flask and the render templates, and render templates is nothing but render the templates from the templates folder, and as well as we imported the request, because to taking the input from the users using this name, okay, from this UI sections to this our server file. And then you import the pandas as PD, and then you import the picals. Okay, then we load our model, just best model or pickle, encoders, and the scalar. Okay, and after that is simply going to creating here one app, and then creating the same method or same function that we created in our this Jupyter notebook file, right? And after that what I can go, you do the same technique, you go same technique, same thing here. If I go on the down, okay, it's reading the kernel, and after the little opening all of the things, you can actually run in this Jupyter notebook as well as in the BS code. But it's right, it's a good choice to actually running this Jupyter notebook on the Anaconda. Okay, I mean the web browsers. So you can see here Anaconda is, I know is snack, but Anaconda is nothing but an environment to actually write in the Python codes. And you can see here Mac predictions, right? So then you can see, just to copy this this what do you call this method in FastAPI file. Okay, and after that we're simply going to calling it out. So for the initial route, we making this prediction equal to none and the probability equal to none, and after the request method is nothing but the post method, and then we have the input data, and we simply are taking this data from the users, okay, from our index.html file. So request.from, inside the from, if it is have the gender name, then save it inside the gender. Okay, same thing here. Then after that is simply to pass in this data inside our make prediction functions, this make prediction functions. So we can convert them into data frame, and after that it will encoding all of the columns. Okay, here you go. And after that it will do the scalar for the numerical columns, and it will predict the output based on the loaded model, and simply it will give you the churn or the no churn, like that. Okay, simple. And later on it will actually rendering the templates with index.html file and passing these predictions to the UI. Okay, if I go on the index.html file, you can see here if the prediction is coming up, then we're simply going to show the predictions and show the probability. Okay, so now if I go on here FastAPI file, and that's our UI, and if I selecting some let's say multiple lines, let's say no, okay, I having some data. Okay, I can chose to use this one. Okay, so gender is female, senior citizen is no. Okay, senior citizen equal no, partner equal to yes, dependent, yes, dependent should be no. Okay, and then 10 row is 12, just give it here, 10 is 12. Then phone service, let's say yes. Okay, phone service yes, multiple lines, let's say no, and internet service DSL, let's say online security yes. Okay, let's say online security no. Okay, then online backup, let's say online backup is yes, device protection no, tech support, let's say no, and streaming tv, let's say no, and all of the things are no. Month to month pepper billing, just yes. Okay, and this is nothing but the monthly charges is 29.85, and this one is nothing but 300. Okay, 385, I hope so. Okay, just I write it down from the actually from the CSV file. Okay, and this is the electronic check, should be check. Okay, fine. And this is the month. Okay, paperless billing is yes. Contract is month to month, and streaming TV is movies is no, and this is no. Okay, just no and no. Okay, and click on predict now. Okay, any problem? Yeah, you can see it's right now churn, and probability is nothing but 56%. Okay, you can give any kind of data. Okay, it's up to you actually, right? And you can see here our application is really working very fine. Now let's checking this out that it is really working in the first API as well. Okay, so what I can do, I need to go on here, and we're going to closing this one. Okay, I'm going to go on our first API one. Okay, that's the first API. So you can also use the, instead of using the actually Flux, you can using here the Fast API, because Fast API is usually used on the development side in the company base. In by default, actually in the company, actually they use the Fast API, the PyTorch. Okay, yeah, but in this one we just going to actually using here the first API in the form of JSON. I mean, simply calling them just like an API, but we are not integrating this index.html file on here. Okay, so same thing, you can see here importing the first API and first API in the from, then we imported the base model class for the pentadig, and import the pandas and the pickle, and simply going to loading here all the files, and then we're creating one app using first API, and also passed here the same predictions model methods in here. And after that is simply creating one class that's called the predictions request, and passing here our base model in the parameters. And then in a constructor, it's called the constructor. Okay, then we have the genders, string, all of the classes which we mentioned on that, the data type of that. And after that, we're simply going to creating here a method that's called a predict method. Okay, this is an async method. This is an async method because it will waiting for the data, right? Then after that, what I can do is simply going to passing this predict request, because this our data. Now this data is coming as a JSON format, okay, from our any kind of API testing applications. Okay, so then we have the input data, and we're simply going to convert them to dictionary, and simply going to pass in this data inside our make predictions. And our make prediction actually give me one result if it is a churn or the no churn, and with having the probability, right? Simply return in this one. So now how can we actually run in these applications? So we need to go on here and go on the terminal. Okay, and after that I can using here the ubicorn. So it having one actually command ubicorn. First API is nothing but my file name. You can first API app and app and reload. Okay, so I'm going to copy this one. I'm going to copy this one, and I'm going to paste it here. Okay, and enter. Okay, so it will reload it now. You can see it is loading right now. So now what I can do, I'm simply going to open the postman. You can see the postman. So I'll be opening this out, and I'm going to click on here, and new will be created, and the request should be the post request, and I'm going to paste here the this link. Okay, so if I go on here, you can see here one link is generated, https 127.0.0.1, and port number is nothing but 8000. And when the user is clicking to the predict button, because we don't have any UI, so we need to give it manually. Okay, predict. That's why I think here the slacks is nothing but the predict. And now what I need to do, I need to go on the body sections and select the raw and select the JSON format, and I'm going to copy this pitch line of JSON files. Okay, I'm going to copy this out, and this is nothing but the data. You can pass it just like a JSON format. You can see gender is female and senior citizen equal to 0, like all of the data actually passing out here, and click on send request. Okay, it will send you the request to the API. Now you can see we get the probability called the churn. Okay, and probability is nothing but 0.565%. Okay, this is how the first API actually look like and how it actually work. Yeah, you can also add here the UI sections on here without using this postman API. We can simply go to testing our API. Okay, you can do the same thing for the Flux as well, because Flux is itself an API. Okay, and the first API itself is API because API is inside the name, right? So you can add it here the UI section as well. Okay, so this is how it actually work, and that's it for today now, and hope you enjoy this full tutorial, and make sure that you subscribe to our channels, and don't forget to share with your friends, as well as don't forget to hit the bell icon, because it will help you to notify our next videos. Okay, and thank you, and bye bye.